Alright guys, Miss Monserrati here with your math lesson since the wind is not letting me do the math lesson online on Zoom, so I'm going to record it. It starts on page 423. It's lesson 8 with the soccer ball. 423, 424, 425, 426, 427, and 428 are your homework. So I will do a separate video to do homework help. But right now I'm going to just do the math lesson. So thank you guys for watching and participating and doing your work, the ones that are doing it. If you're not, then you're not even hearing this. But I know who you are that are doing your work, and thank you. And it will help you, right? These are multiplication properties, and a lot of the teachers are like, why do we have to learn these names? I'm going to keep teaching them because I had to learn them in college. And if I would have learned them in elementary school, by the time I got to college, it probably would have been easier. So, and we're doing this in high school as well. A coach had 16 players in each of 2 groups. Each player scored 5 goals. Find the total number of goals scored. So this might be confusing because the way it's worded. A coach has 16 players in each of 2 groups. Almost like he has 2 teams, right? There's 16 players on one group and 16 players in the other group. So that's going to be 16 plus 16, 32 players. Each player scores 5 goals. So I'm going to take my 16 times my 2, multiply it, and get 32, and then I'm going to do it times 5 to find how many players are, or how many goals my players scored. But 16 times 2 is 32 times 5. 32 times 5 might be a little bit hard, right? It's going to be 160, maybe. I got to double check my math. But I'm going to do it an easier way. Yeah, it's going to be 160. Since you can easily multiply 2 times 5, right, I'm going to use this associative property of multiplication. It states that the way the factors are grouped together does not change the product. Any way I multiply these 3 numbers together, I will get the same answer. It's almost like they're a new fact family. I put these 3 numbers together. So it's easier for me to do 2 times 5 than it is to do 16 times 2. And then I know when I have 2 times 5, I'll have a 10, right? And 10s are easy to work with. So I'm going to take my 16 times 2 times 5. I'm going to move my numbers around. That's the associative property. I always think of the associative property because it's the one that has parentheses around the numbers. So see the parentheses, right? And remember, I do the numbers in parentheses first. In multiplication, I can move them around. Addition, subtraction, I can't always do that. But multiplication does give me this law, this rule, that tells me I can multiply these 3 numbers together in any order I want. So I'm going to switch, and I'm going to have, instead of 16 times 2 times 5, I'm going to have 16 times 2 times 5. I'll do the 2 times 5 first. Right, I can only do work with 2 numbers at a time. 2 times 5 is 10. 16 times 10, I just take my 16 and add a 0 at the end. 160. So these players scored 160 goals amongst all of them. On to the back. There's also a commutative property of multiplication. It just says if I have 2 numbers, I can multiply them either way, and I will have the same 2 numbers here. So they're kind of doing finding an unknown, like an algebra problem, right? If this was A, what number goes right here? Well, I have 35.5, 35.5. 17, I'm missing my 17, right? It's going to have to be the same number right here. So my unknown is 17. The commutative property means I can move them around. If your parents commute to work, it means they drive their car to work, right? That doesn't look like a car. Anyway, next problem. The identity problem, property of multiplication. Your identity is what you look like, who you are. So the identity problem property of multiplication just tells me that if I multiply this number times something, it's going to stay the same. It's not going to change it. Hopefully you guys know the number I do in multiplication is 1. Right? I have a similar identity property in addition. I have a similar property for commutative and associative in addition, but not in subtraction or division. So the unknown is 1. I have to draw lines to match the multiplication property used in each equation. This one is just moving these two numbers around, and I know that's the commutative property. This one has those parentheses. When I see the parentheses, I think associative. Is that what they're doing? Yeah, instead of doing 8 times 2 and then 16 times 3, I'm going to do 8 times 2 times 3. 2 times 3 is 6. 6 times 8 is 48. Right? It just makes it a little easier problem than saying 16 times 3. If I did 16 times 3, I would get 48. I would get the same number. That's why I can move these numbers around and move them around. And it makes the same answer. 6 times 3 is 18. Carry my 1. 3 times 1 is 3 plus 1 is 4. I still get 48. So that I call the associative property. The next one, identity. If I multiply any number times 1, I'm going to get the same number. It does not change its identity. So, it says, explain how you could use mental math and multiplication properties to find 5.5 times 50 times 2. Well, I would like to do 5.5 times 50 times 2. 50 times 2, I know, is 100. Right? And 5.5 times 100, all I'm going to do is annex 2 zeros onto the end of this number. Right, so 55 times 100, I'm going to say 5.5. I'm not going to put my decimal place there. I'm going to need to put it in a different place in my answer. But I know 55 times 100 would be 55 plus 2 zeros on the end. Now I'm going to do my next part. I need to add my decimal place back in. In my problem, I had 1 decimal place. So in my answer, I'm going to have 1 decimal place. So my answer is going to be 550. I can get rid of that extra 0 on the end. All right, on to the next page. My next page says, use properties of multiplication to find each product mentally. Show your steps and identify the properties that you used. Mental math, right? Uh-oh, I just did that similar problem right here, right? I did 5.5 times 50 times 2. Look at this, 5.1 times 2 times 50. So I'm going to move these numbers around. That's going to be the associative property. Right, it's really called the associative property of multiplication. I should have given it a capital A because it's the name of the property. It's the associative property of multiplication. I'm going to abbreviate multiplication. But all I do is I move these two numbers around. So I'm going to have 2 times 50 is 100. Right, this is all I'm doing is instead of doing 5.1 times 2, I'm going to do 5.1 times 2 times 50. It says mentally, so I really am not writing anything down. I'm doing it for you guys. So I know my numbers are 5, 1. I know 2 times 50 is 100. I just did it, right? I just said 50 times 2 is 100. I know 2 times 5 is 10, plus add the 0 back on is 100. So I'm going to put 2 zeros in my answer. I'm going to count how many decimal places are in my problem? Just 1. So my answer, there's just going to be 1 number behind the decimal place. So my answer is 510. Right? I can get rid of zeros after the decimal place. Only other digits I cannot. I can get rid of 1, 2, 3, 4, 5, 6, 7, 8, 9. But I can get rid of 0. All right, my next problem. 4 times 2.5 times 6. Oh, might be such a hard problem for you guys. But I know 25 times 4 is 100. Right? That's what I'm going to do. I'm going to do this associative property. I'll write it down lower this time. I'm still doing the associative property. I'm moving these numbers around. You might want to do 4 times 6 and 24 times 2.5. But I see this 25 times 4. I know 4 quarters is $1, which is 100. So that's what I'm going to do. I'm going to move my 4 times my 2.5 times 6. Right? I'm doing mental math here. I'm going to say it's 100 times 6, which is going to be 600. And then I need one number behind the decimal place because that was my original problem. I had one number behind the decimal place. In my answer, I have one number behind the decimal place. My answer is 60. But if you don't believe me with the 2.5 times 4 is 100, I can do my math, right? 5 times 4 is 20. Carry my 2. 4 times 2 is 8 plus 2 is 10. In my problem, I had one decimal place, so my answer, I'll have one decimal place. Ooh, and I messed up. Good thing I double checked myself. And I should have known that. It's not, 4 times 2 is not going to be 100. 4 times 2 is going to be 8 plus a 0.5. So good thing I double checked myself, right? So now my answer changes. Actually, it doesn't, huh? I still have my number behind my decimal place. I'm still going to have 60 because I'm going to have 10 times 60. So it still worked out. Huh, interesting. All right, next problem. 9.8 times 500 times 2. So I'm going to do 9.8. I'm still doing the associative property. They asked me to write my properties. 9.8 times 500 times 2. 500 times 2 is 1,000, right? 2 times 5 is 10 plus 0 plus 0, 1,000. So I'm going to have 9.8, but I'm not going to put my point yet because I need to do my math first. So I'm going to have 1,000 is 3 zeros. 1, 2, 3. I'm going to put one decimal place because my problem had one decimal place. My answer is 9,800. On to the next problem. All right, it says 1.4 times 50 times 20. 50 times 20 is 100, right? And 100 times 1.4. So I'm going to say 1.4. I'm not going to put my point yet. And I'm going to put my 100 zeros, right? 100 has 50 times 20 is not 100. It's 1,000. Hopefully I said it right. So 50 times is 1,000, so I need 3 zeros. And now in my problem I had 1 0, one number behind the decimal place. So in my answer I have one number behind the decimal place. My answer is 1,400. Sometimes I want to double check my math answers to make sure I'm doing it right. All right, my next one. Find the unknown in each equation. Circle which property you used. Look, they wrote them for us. How nice. So 19.5 times something equals 19.5 times 1, right? My gray square is equal to 1. And this is algebra because I have an unknown there. And the property that uses multiplying times 1 to find itself is the identity property. It still has the same identity. This one, I have 34 times 65 is equal to 65 times 34. It has to be a 34 here, right? And I know I can multiply these this way, or I can swap them and do that way. And that is the commutative property. My next one, 2.1 times something equals 4.3 times 2.1. 2.1 times 4.3 is going to equal to 4.3 times 2.1, right? I can switch those numbers around and do them either way I want. It's the commutative property. My gray square is equal to 4.3, right? We don't even have to do any math on these problems. How fun. This one, oh, I see those parentheses. When I see parentheses, I automatically think of the associative property. I, for myself, have to do little tricks in my brain to remember stuff. So I just see those two S's and they remind me of parentheses, and that's how I remembered it when I was in college and I had to learn this stuff. So 17 times 2 times 5 is the same as 17 times 2 times 5. Right? I can do 17 times 2, 34 times 5, or I can do 17 times 2 times 5 is 10. My answer is going to be 170 if I multiply this out. But all they're asking me is what number is missing right there. What gray number is right there? I can see the number that's missing is 2. And that's the associative property. On to the back. All right, so here is Elijah. And 2 of his friends are paid $2 each. Sorry, are paid $20 per afternoon for stuffing envelopes. You guys might be like, how do you stuff an envelope? All you do to stuff an envelope is you take an envelope and you put something inside of it. So usually, this is a job for someone, right? Someone has to put a lot of stuff in envelopes. So I'll just put something inside of my envelope. I'm stuffing my envelope. So that's what he's getting paid, $20 per afternoon, right? Not per hour. Maybe he did for how long it took him. Maybe an hour, 2 hours, 3 hours, but he got paid $20 per afternoon. So for one afternoon, he got $20. Right, afternoon is after 12 o'clock. He probably worked from like 12 to 2 or something. I don't know. I'm just guessing. So, here is all right, I gotta do one more minute and then I gotta go to a meeting. Elijah and 2 of his friends, right? So this is where I know they're getting paid $20 per afternoon and they're working for 5 afternoons. What is the total amount of their earnings all together, right? It doesn't say about. They want to know my exact, how much did these guys earn all together? Because it says total amount of their earnings, right? Well, there it's referring to these 3 people, Elijah and his 2 friends. So Elijah plus 2 friends is going to be 3 guys. They each earned $20 per afternoon, and they worked for 5 afternoons. So I can switch this around. Instead of doing 3 times 20 and then times 5, I'm going to do my 5 times my 20. I know that'll give me 100. So I'm going to say 3 times 20 times 5. I'm using the associative property of multiplication. 20 times 5. So now I'm going to have 3 times 20 times 5. Well, 2 times 5 is 10. And I need to put that 0 back. So this is going to be $300. These boys earned stuffing envelopes for 5 afternoons. So here we go. Replace the gray square in 8.7 times 5 times, 8.7 times gray square times 5 with a number greater than 10 so that the product is easy to find mentally. So I need to find, I'm going to replace this with a number that is greater than 10 and to make it an easy way to find this answer. How about 20? 20 is bigger than 10. So let's do that. I'm going to say 8.7 times 10. It wants me to explain as well. Sorry, times 20. A number greater than 10. 20 is greater than 10. Times 5. I'm going to rearrange it using my associative property. So I'm going to say 8. Oh, I don't need the parentheses either. I'm going to say 8.7 times 20 times 5. And maybe because it says explain, here's my explanation. I'm going to say associative. I should do a capital A since it's the name of the property. Associative property. So if anyone was looking at this, they would know I explained it. I probably should put of multiplication as well. I'm going to do of mult. I'll abbreviate multiplication so I don't write it all out. So 8.7 times 100, right, is going to be 87 times 20 times 5 is 100, so I'll put my 2 zeros. And then my problem has 1 number behind the decimal place, so I'm going to put 1 number behind the decimal place. So 870 is my answer. So now they want me to explain. So I can say I multiplied. I will write out the whole word this time. 20 times 5. Which equals 100. Sorry, I'm trying to figure out where I can fit this. Which equals 100. And 8.7 times 100 equals I'll put my 2 zeros back and move my decimal place. I put my decimal place, or my decimal point, after I did my multiplication, right? That's what it kept telling us. First we multiply, then we put our decimal place. Maybe I'll put a little arrow right there so they could see. That's where I put my decimal place. All right. Each juice box contains 6.4 ounces. Each value pack of juice holds 10 juice boxes. If you have 50 value packs, how many ounces of juice do you have? So I know there's 6.4 ounces in one box. So if there's 10 boxes, I'm going to multiply it times 10 to find how much there is in this value pack, right? It's when all of these juice boxes come together in a big package. I have 10 of them. So 6.4 ounces in each times 10. And then it told me I have 50 value packs. So I'm going to multiply times 50. So I still have, this one I'm just finding my answer, right? I'm finding how many ounces of juice. I'm going to rearrange my problem. I'm going to say 6.4 times 10 times 50, which is going to be equal to 6.4 times, so 10 times 50. So 1 times 5 is 5. Plus, I'm going to put my 2 zeros back because I didn't have 1 times 5. I had 10 times 50. So after I put my 2 zeros back. So I'm going to say 6.4 times 500 equals, I have to figure how many ounces of juice. I'll do my math over here, right? I can do commutative property. I'm going to put the big number on top. I'm going to say that equals 500 times 6.4, which equals, so I'm going to do my math problem here. 500 times 64. At the end, I'm going to put my decimal place back. All right, so first I'm going to multiply by the number in the ones place. 0 times 4, 0. 0 times 4, 0. And I'm lining up my numbers under my problem. 5 times 4 is 20. Now I need to multiply by the numbers in the tens place there. So I'm going to hide my 4, right? In my problem, it's really the ones place because it's 6.4. But the way I wrote it, it's in my tens place of my number. So I already multiplied by the number in my ones place. So I'm going to put a 0 here to just hold that place value so when I add, I don't get messed up. Now I'm going to multiply all the numbers on the top times the number in the tens place. 0 times 6, 0. And I'm lining them up nice and underneath the numbers where their next place. 0 times, right? See, 0 times 6, you'd want to write it right here, but I don't. I write it right. The next place value is over is right there. So 0 times 6. Now I'm going to do 5 times 6 is 30. Add all these numbers together. Or both of these numbers together, not all. 0, 0, 0, 0, 0, 0, 0, 0, 0, 2, 0, 2, 3, nothing, 3. In my problem, I had one number behind the decimal place, so I need one number behind the decimal place again. I'm going to say there's 3,200 ounces of juice. So 3,200, right? They're asking me ounces. Ounces. I measure my juice, how much juice I have. So there's my answer. I don't need that extra 0 there after the decimal place, right? I'm going to just say 3,200 ounces. Uh-oh, sorry. I got to go to a meeting. Ah!